Do you both know how to do lab assignment ECM152 about concrete?
Yes, we know.
Let me show you.
This is video that tests for workability of concrete. The ease with which one can work with concrete is called workability. This can be measured using a simple test that called the slump test. Then this video will show the procedure. Slump contest is a simple and always used on site to assess the workability of concrete mix. The test should be conducted at the beginning of concrete operations. The apparatus for conducting the slump test essentially consists of a metallic mold in the form of a frustum of a cone with a base plate. A steel tamping rod of 16mm diameter and 60 cm height is to be used for compacting. The internal surface of the mold should be thoroughly clean of moisture. The mold is placed on a smooth horizontal rigid and non-absorbent surface. It is then filled in 4 layers with the thickness of each layer being more or less 1/4 of the height of the mold. Each layer should be tamped 25 times evenly. The concrete is leveled with a trowel so that the mold is filled exactly to the top. The mold is then removed by raising it gradually. This operation should be carried out with any jerk and vibration. The slump may either be a true slump or shear slump or collapsible slump. The true slump is the desired form, a slump that we require, and then in harsh mixes, the concrete slide in an inclined plane. This is known as shear slump. In collapse slump, the concrete collapses as soon as the cone is removed, usually occur in very wet mixes. The concrete demonstrating is near a collapse slump is considered unsatisfactory. Let's just say in case of slump result beyond the specified limit, the mix proportion needs to be adjusted, especially the water content. For the summary of tests for workability of concrete. First, it is advisable to assess the workability of concrete mix using a slump cone. Second, ensure that the cone is filled in a proper manner as indicated. Third, notice the type of slump. Like shear and collapse slump are undesirable. Lastly, adjust the slump to the desired value by changing the proportion.
For our information, concrete is a material that produced from a mixture of cement, sand, aggregate and water, but according to a specific and effective mixing ratio. Then the equipment required is a shovel, trowel, compaction rod, compaction machine, and a concrete cube mold that made of steel. First of all concrete mixing ingredients, which is aggregate, sand and cement, weighed first by according to the prepared concrete mixing ratio. After weigh all the ingredients, we will pour all the ingredients and mix well on a tray, or we can also using a mixing machine to be more easier. Next, add clean water according to the proper ratio and mix all until smooth. The concrete cube is prepared. Fix the base and surrounding walls by using suitable bolts and nuts. But make sure the cube mold is in a strong and neat condition to prevent leakage when concrete is poured into it. Then the inner surface of the cube is rubbed with grease or oil first, and then put the concrete into the cube mold and heat it using a rod 25 times uniformly throughout the concrete. This step is repeated on the second and third layer until the concrete cube mold is full and solid. And the top surface of the concrete is flat and need to level it first and then leave for 24 hours. After 24 hours, the cube mold is carefully opened and placed in water tank. It needs to be left submerged to undergo the curing process for 7 14, and 28 days. After curing for 7, 14, and 28 days, the concrete is removed from the emulsion and placed in a compression machine. Compression pressure is applied slowly until the cube breaks and the result can be recorded. The purpose of 7-day and 14-day concrete test is to predict whether the desired strength at 28 days can be achieved or not. So this is one of the tables that we can refer to find out the time periods and percentage of concrete strength. So we can summarize that the longer the concrete is soaked in water, the strength of the concrete is getting higher.
So, for steel tensile testing, we need extensometer, digital caliper, tempered steel, quenched steel, stainless steel, and universal testing machine. So, here the step of steel tensile testing. Firstly, we need to prepare the steel specimens. Second, measure and record initial dimensions. Third, clamp the specimen in the universal testing machine. Then, we need to set the machine parameters on the control panel or software. Next, start the tensile test. After that, we need to monitor load and extension data as the sample elongates. We can observe material behavior. Once the specimen breaks, the test finish and remove the sample. Lastly, we need to analyze the result using recorded data to determine mechanical properties.
What is a bend test? It's a form of mechanical testing that can be performed on a universal testing machine. Engineers use bending testing to measure of behavior of steels subjected to simple beam loading. While many people thinking the material as being brittle, they are often related ductile, which allow them to be used as a support structure like skyscraper, bridge, and others. Bending testing is performed to mimic realistic loading situation. A bend test is performed using a 3-point or 4-point bend fixture, which apply force in a different ways depending on the requirements. A material can be tested to be a specific load or strain. Properties measured include flexural stress, flexural strain, flexural modulus, and flexural offset yield strength. For more information, here is the demonstration of bending test. So first, you are measuring the steel that want to be tested, and then set up the force pressure to bend the steel, and then place the steel you want to be tested under the point, and you are ready to test the bending test of steel. Here you can start the machine and press the steel that be tested until it breaks. You can test different type of steels using this bending test.
Steel is an alloy of iron, carbon, and other elements. Steel has less strength and more low cost than other materials. Steel is available in various forms, for example, solid, plate, and hollow form. And then type of steel that usually used in construction is alloy steel, carbon steel, reinforced steel, and stainless steel. Now we go through to the other material, which is concrete. Concrete is a composite material that usually used in construction. Concrete is a combination of cement, sand, and aggregate by according to a mixing machine. The type of concrete that usually used in construction is permeable concrete, reinforced concrete, high strength concrete, and then normal strength concrete.
For this section, we are looking at the engineering properties and characteristics of both concrete and steel through a few common tests. For concrete, use the slump test to check the workability of fresh concrete, basically how easy it is to mix and place. Then, the cube test is used to measure compressive strength, which tells us how much load the hardening concrete can resist. For steel, we have the tensile test, which measure how strong the steel is when being pulled and how much it can stretch before breaking. We also use the bending test to see how well steel can flex without failing. Together, this test helps us understand the key engineering properties like workability strength, durability strength, and overall performance of the material in the construction.
Steel, like any construction material, has its own advantage and disadvantage. Understanding both sides helps us to choose the right material for different type of structure. So this is advantage and disadvantage of steel in construction. For advantage, steel components are usually prefabricated in the factory. Steel also 100% recyclable, environmentally friendly, and also reduce construction risk. For disadvantage, steel is quite expensive and also fire risk, which they lose strength at high temperature. In construction, concrete is one of the most widely used materials. Although it offers many advantages, it also has several disadvantages that must be considered. Here is advantage of concrete in construction. It can withstand with high pressure and also good fire resistance. It can perform better at high temperature. Concrete structures are very heavy, so foundation cost will be higher. Concrete needs a curing period of 7 to 28 days to achieve full strength.
Here is application in Malaysian civil engineering project in steel materials. There are many applications in Malaysian civil projects in steel materials. For example, steel used to make beams and columns, make rebar, alternative to wood, and then create roof and walls. And the last one is create frame stairs. For each application has its own advantages. I will explain one by one. First of all, steel is used to make beams and columns because it is strong, durable and cheap, and then it is easy to shape and making it suitable for building construction as well. And then the second one is make rebar that we call reinforcing iron. It is used because of its strength and low cost. It helps strengthen the structure of the building. For the third one, steel used to alternative to wood because it is more durable and requires less maintenance. It is also more economical in the long run. Then create roof and walls. Steel is suitable for roof and walls because it is light but strong. It can durable and doesn't add weight to the structure. And the last one, frame stairs. Steel is used to build stairs because it is heavy duty, easy to cut and shape, and it is also economical and flexible for design. So that's all from me. Bye bye.
So now we go through with application in Malaysian civil engineering project in concrete material. First of all, driveway and patio. Like concrete is used for driveway and patio because it is durable, long-lasting and requires low maintenance. Second, sidewalks. Like concrete sidewalks are preferred due to their strength, durability and minimal maintenance needs. Third, concrete parking area provide better safety, lightning efficiency, and longer service life than asphalt. Next, water reducer and superplasticizer are used to improve workability and achieve the required slump in high-performance concrete. After that, concrete is commonly used for foundation because it is strong, durable, and resistant to fire and weather. And lastly, concrete is suitable for mid and high-rise buildings due to its structural stability, safety, and durability. So that's all for application in Malaysian civil engineering project in concrete material.
Sustainability practices in concrete. Use crushed concrete instead of natural aggregates to reduce landfill waste. Then replace cum cement with industrial byproducts like fly ash or slag to cut emissions. Then reclaim and reuse water from concrete plants. Lastly, create durable structure that require repair and replace material use. Innovation for concrete. Firstly, turning the concrete into a carbon sink. Secondly, use self-healing concrete, which is concrete that contains bacteria or capsule that activate to repair cracks. Third, use light transmitting concrete to reduce electricity needs for light. Then use low carbon cements to develop new binder like limestone, calcinate, clay cement. Lastly, use 3D printed concrete that allows for precise material use and reduce waste. Sustainability practices in steel. Firstly, we need to maximize recycling. For example, use electric arc furnaces to cut energy and raw material needs. Secondly, use waste heat recovery to reduce energy consumption. Third, use renewable energy such as solar or wind. Then, reduce fresh water use through recycling and advanced treatment. Lastly, optimize process to minimize raw material waste. Passion for steel. Firstly, use hydrogen instead of coal as reducing agent. Next, we should use renewable electricity to eliminating carbon emissions. Then, capture carbon dioxide from emission for underground storage or use. Lastly, use data for better resource management and efficiency.